All right, hey everybody. We're here in Gig Harbor, Washington on the 21st of, what is it? June already. We are going to do some drone flights today. We have the Matrice 300. Right, David?
Yep, new 350, 300, basically the same thing. We've got DJI L1 here, and then DJI L2, and then 3 of the Inertial Labs RESEPIs. So the LiveVox AVIA version, same as the DJI L1 sensor, and then 2 from Hosai, the regular XT32, dual return, 120 meter range, and then the big boy, triple return M2X, 300 meter range. We're going to do some accuracy tests. We're going to do some vegetation penetration at 400 feet, see where all the returns and all the differences make up in all these sensors.
Yeah, so it should be a fun day. We're going to test for several different things, one of them being penetration. Now, the reason we're out here at my house in Gig Harbor, and I'll show you why we're checking penetration, is if you're not from the Pacific Northwest, you might not understand exactly what sensors have to deal with. So, here's a nice little cut of it. If you look at that forest, we have almost a triple canopy. We have the trees up high, we have a mid-level set of trees, and we have some pretty intense ground cover. I mean, I don't even know if I can see the ground with a camera. So that'll be one testing method. The other will be noise, and also how much of vertical surfaces we get, checking angles of collection. Should be a fun day. So we'll get after it. All right, so first up we have the L1 on the Matrice 300. David, tell us about the L1.
So L1, nice, pretty unique in terms of LiDAR. It's on the 3-axis gimbal. So we won't be testing that out. You know, we're not doing any facade scanning, but something to consider. You got the nice stability, 70-degree field of view on the laser, 450 meters of range. In the multiple return modes, you're up to in the 400,000 points per second range. So we'll be testing that out. 10 centimeter accuracy horizontal, 5 in the vertical. So it should be the least accurate of results, but it's definitely the lowest cost today. I think even new these days, it's last time I checked in like the low $8,000 range. So for LiDAR for 8,000, that's a sweet deal. Test it out and see how it compares to all the modern sensors.
How do you think it's going to do on penetration compared to the other ones?
I think it's going to be the worst.
The worst?
So
all right,
and I think we'll even see a difference between that and the RESEPI with the same LiveVox sensor. So, but right. we'll have to wait and see.
Hell yeah. All right, so after a quick firmware update, well, quick is a relative term, we flew the L1. It's back home now. Which one are we flying next, David?
L2.
The L2.
So same route. We ended up, because it's a small site here, we're doing it at 400 AGL, and we moved it to 80-80 overlap, 80 side, 80 front. It was about a 7.5 minute flight, then a little bit more for the IMU calibration and all that, but sub 10 minutes, good flight. We put it on the triple return mode. So wait to see what we get.
And what you guys just witnessed there was an expert hot swap of the batteries. We're all charged up and ready to go. All right, David, tell me about the sensor.
So DJI L2 proves on the L1. Pretty much everything except for range. So same 450 meters. You're going from 3 returns to 5. So with the 5 returns, you're at a whopping 1.2 million points per second. Your vertical accuracy is dropping in half, so going from 10 centimeters to 5, and the vertical is going from 5 to 4 centimeters. So a little bit of difference there. Same kind of 3-axis gimbal, same IP54. The camera's a little better, mechanical shutter on this one, and a little higher specs. But overall, the main difference is in the warm-up, and then of course in the extra returns.
Was there a flight time estimated difference between the L1 and L2?
No, it was roughly about the same, still 7.5 minutes. So we just did our flight with the L2, same 80-80 overlap, 400 feet. Altitude seemed to be, no warm-up period, which was nice, but there seemed to be quite a, double the length of all the back and forth, all the calibration within the flight, which is interesting. See if it makes the difference. We're doing vegetation penetration, so we used all 5 returns on our flight, and now we're going to move to the Inertial Labs, and we're going to go to the AVIA first. See you guys then. What's the name of there?
Going white.
Yep.
Oops. Okay.
And then there's a little button on the side here. You might not have to do it on the...
God, I hate that. Doesn't feel like there's no click.
The L1 and L2, it's like a little thing you got to spin by hand.
Okay, it's definitely on there.
Yeah, it seems...
I'm tempted to have you check it and make sure I didn't put fingerprints on it again.
Yeah, you had it good. Great.
Well, while you're working on that, David, tell us about the sensor.
So we got Inertial Labs basically taking the same Livebox AVIA sensor and then putting their tactical grade IMU on it and then matching it up with a 24 megapixel Sony APS-C size sensor. So gives us some better colorization and better photogrammetry. If you want to use the photos as well, you could take those off. We're going to have enough overlap, 80-80 as an example of what we're doing, that we could also take the images, just use them if you wanted to get an ortho of the site.
So is this the RTK sensor?
Yeah, this is the PPK. So,
okay, PPK.
So
gotcha.
the DJI L1, DJI L2, they use the one that's built into here.
Okay.
On all the Inertial Labs, they have an upgraded Novotel, which is owned by Leica.
Okay.
Receiver that's in them, and so it's a little higher end. So you do have to attach this antenna, which is just a GoPro mount.
Okay.
What do you think this one's going to do compared to the L1?
Definitely more accurate. I think it'll do a little bit better on the penetration, but you should be in the couple centimeter range, 3, 4, 5 instead of 10 of the L1.
What about the L2?
L2 would probably be pretty comparable. I think that'll be probably the closest matchup of any of the 5 sensors.
And what's the price point on this?
About 15 grand-ish these days. So.
Super reasonable, isn't it?
Mm-hmm. So, and then you're not tied into the DJI. You could put this on a vehicle. You could put it on, any other NDAA drone, Whisper, Aspired Flight. All those options it's able to support on there. Got an XT60 port on the side, so you can take it about anywhere. And on all the Husai ones, you can also take it off and just do handheld for the slam. So if there is something you can't fly or you just can't get the surface of, you can always walk it too.
Well, now that is super duper interesting to me. Think about it. More about this sweet drone.
So we're all set up, RESEPI AVIA. We've been collecting with our StoneX receiver over there. Doesn't matter the brand or anything, we just need a raw file. You can use that from your local courier station. So we're doing all PPK. You can't do RTK, it makes it a little more complicated. And of course with RTK, it has to be real time. So if you have some kind of error just in your data signal, you essentially screwed the flight. That's why we mainly suggest doing the PPK workflow, prevent all that. So from some differences between using a third-party payload and the DJI is that we're going to have to power this on separately. We have a better GNSS receiver inside the LiDAR unit here, so we have this separate antenna for greater performance. We're going to have to turn it on separately, power it separately. We're manning the mission from our phone. You can just push the button on the side. Basically, we're just verifying we're seeing satellites. We're good to go. And then from calibration up in the sky for the IMU on here, essentially you're just doing one figure eight, then you're good to go for the rest of the flight. The DJI ones, it's built in, it's nice, but it's looking like going to be like 7-8 minutes for what we've been doing on the flight times. And on here, you know, conservatively, you know, we're 5 minutes or less in the same exact flight plan. We're flying with RTK for the drone positioning. Everything's the same, just in the fact, you know, the calibration is going to save you a couple minutes. So we'll be curious to see the results.
I'm looking forward to it.
So same exact tactical grade Inertial Labs IMU, same exact 24 megapixel Sony APS-C size, Super 35, however you want to say it, size sensor. Same package, same everything, just instead of having the 70-degree field of view Livebox AVIA, we got the 360-degree 32-channel Hesai XT32. So the fan favorite, you've seen it on so many different things, Spheral Orbis, all the GOQs, yellow scan, you name it. It's probably the most popular sensor overall that there is, and then just RESEPI's take on it with their special sauce being their IMU, being the one actually making it instead of just being an integrator like the rest. So this is the Mac Daddy. Not that this one's not so.
So my buddy,
Bet me.
you're the Daddy Mac. Are we putting it on? Or am I just looking at it?
You're just looking at it.
Oh yeah.
So we got
Tell me about it.
this is the XT32. So same exact family, just a little bigger brother. So it goes from this total payload is 1.2 kilograms. The regular XT32 is 1.7. So you save half a kilo. And then we're still 32 channels, but on here we're upgrading to a third return, and then 300 meters of range instead of 120. So
what does that do for me, that half kilo?
increased flight time and more drones you can use it on. So the regular XT, you couldn't use it on something like the popular FreeFly Astro. This lighter payload you could. So those smaller drones. Same with the Whisper Sky Scout. You could put this on there, but you couldn't do that on the regular XT. So it unloads a new class of smaller drone that you can use. This is also so lightweight that first LiDAR available on the Wingtra, same exact Inertial Labs, same everything. This of course has the camera.
What's the camera?
I was going to ask, tell me about the camera.
Same 24 megapixel Sony as the rest of the lineup. It's from an stripped from an A5100. So give you that full APS-C size photos.
Nice. So you'd say with the lighter weight and longer range, you can clear a lot more property?
Significantly. And with the triple return, you're seeing a lot more anyway. And not even with the increase, you know, you can, just from the increased range, you can fly higher, but you know, you're also, you know, which we'll see in this test, that at 400 feet, you know, I'd say at 50 meter AGL, you know, 150 or so, between this and the regular XT on a hard surface, you're not going to see much difference, but you get up to the 400 level, that's where you're going to start to see.
What is a triple return? Is that phase-based and time of flight, or what are we talking about there?
It's all the same. I'm not sure what would...
So the triple return is how many returns it reads off of the same laser pulse. So with aerial LiDAR, a lot of times you're doing vegetation, and like a part of it will hit a leaf.
Okay.
And sometimes that will come back, and that's the first return, it reads that. Then a part of the laser will go down a little bit further, bounce off something, and come back, it will get that reading too. So the more readings you have, the more different surfaces you could actually get from the same laser pulse.
Okay.
It's like using the double scan mode or whatever that's called. So to recap things, we flew DJI L1, DJI L2, and then 3 third-party payloads, part of the RESEPI family from Inertial Labs. So Livebox AVIA sensor, same as DJI L1, and then 2 from Hesai, the regular XT32, and then its older brother, the M2X.